go to creatine and creatinine. Okay, let's look to a question and then we will go to the discussion of creatine and creatinine. Guanidoacetate is formed from dash in dash. Okay, guanidoacetate is formed from dash in dash. Arginine and glycine in kidney, methionine and glycine in liver, cysteine and arginine in liver, citrulline and aspartate in muscle. Okay, I'll just repeat the question. Guanidoacetate is formed from dash in dash. Arginine and glycine in kidney, methionine and glycine in liver, cysteine and arginine in liver, citrulline and aspartate in muscle. Okay, so let's look at how is creatine formed. Now, first thing first, we are now discussing about creatine. We are discussing about creatine. So, creatine, the formation starts with the arginine and glycine coming together to form ornithine and guanidoacetate. Okay, ornithine and guanidoacetate. This takes place in the kidneys, right? Then what happens is this guanidoacetate receives a methyl from S-adenosine methionine. Okay, in our previous session we had learned about transmethylation reaction and the addition of methyl groups, how activated methionine can transfer its methyl group to a compound and in itself get converted to S-adenosine homo-15. It's a typical example of that same. So we have got guanidoacetate. This guanidoacetate now will accept the methyl group and form the creatine. We are forming the creatine. Okay, so coming back to our question, that guanidoacetate is formed from, the answer will be arginine and glycine in kidney. Okay, arginine and glycine in kidney. Okay, and then it gets methylated to form cysteine. Now, let's quickly look at few points about creatine and creatine phosphate. Now, it occurs in muscle in high energy compound in its phosphorylated form, creatine phosphate. That is, creatine phosphate is a high energy compound which we get from creatine and is stored in muscle as a high energy compound, because our muscles, our skeletal muscles or cardiac muscles, they require very high amount of energy. To provide this energy, we store the energy in the form of creatine phosphate. And the interconversion between creatine and creatine phosphate is the driving force behind muscle contraction. The energy required is between the interconversion between the creatine and creatine phosphate. Creatine and creatine phosphate. Right? Now, creatine phosphate reversibly donates the phosphate to ADP to form ATP. And when the ATP levels are depleted during intense muscular activity, it is replenished by this mechanism, and this is called as Lohmann's reaction. This is called as Lohmann's reaction. The enzyme required for this is creatine kinase, or sometimes it was also called as creatine phosphokinase. Creatine phosphokinase, that is CPK. Creatine kinase or creatine phosphokinase. So let's look at the reaction. What is happening? We have creatine, right? This creatine is phosphorylated to creatine phosphate and stored as a high energy compound. Okay, and whenever there is a depletion of ATP, the phosphate group is donated back to ADP, the forming ATP, and creatine is received back. So this is called as the Lohmann's reaction. This is called as Lohmann's reaction. Okay, now let's look at what is creatinine. Now we are going to tell the story of creatinine. Okay, now what is creatinine? Creatinine is if you look at the structure of creatinine, creatinine is